networks. It is a class of artificial neural network where the connections between the nodes can form or can create cycles. This allows for outputs from some inputs or from some nodes to affect the subsequent input to the same nodes. And what this allows us is to form or identify the temporal network behavior. So what is temporal? That is time-based or time-based information that you have. It can be in the form of, you can also understand this in the form of timestamps, like the actual time. So if some information is dependent on the time, a sequence is dependent on the time, so temporal networks, temporal network behavior can be captured by your neural networks. They are able to capture the relationships that exist in temporal behavior. And what is the general okay, so we studied in the previous lectures, we studied CNNs, convolutional neural networks, and the main difference we can say on a general perspective is that the CNNs are incapable of effectively interpreting the temporal information. So what the RNNs or the recurrent networks are able to do is that RNN has the ability to process temporal information. What this means is that your data that comes in sequence for example, you can say a sentence. So if I say this is lecture number 15, so this will precede is, and is will precede a, lecture will precede number. So this is the temporal relationship that we have in the words. So the relationship in the language, like the nouns, verbs, conjunctions, they all form a specific structure, that is sequential structure. So RNNs are able to capture these relationships. Some of the types of recurrent neural, some of the types that of such type of algorithms are starting with your recurrent neural network. Then you have your LSTM network and some of the attention models that we have in research. They are able to identify the time-based information or a sequence order-based information. They are able to capture that. So what is sequential data? Most of your data that exists, our data are sequential, such as speech. It could be existing in text, or it could exist in an image. Even that data, we can say that we can have information that is sequential. So what are the different in general, what are the available models in the deep learning that we can use for sequential data? Are convolutional neural networks, then we have your recurrent neural networks, and in the CNNs, what we are trying to find is the local feature in your image within a sequence, from a sequence. For example, if we studied this example in the convolutional neural networks. So if every point is representing a pixel, so identifying the pattern in these 4 pixels will extract the local features within this image, and we can use these multiple local images, local features. These are local features. We can use these features to basically classify this image as an X. Okay, so this is what we are trying to do. Then we have the recurrent neural networks, the topic for today. We are trying to capture the features of the past. So what does this mean? In the CNNs, we are trying to find the relationship existing within the image. Whatever you have right here. And you're trying to extract that information, or extract the, we call that feature extraction part. In the feature extraction part, you're trying to extract the local features. And why do we need the local features? To determine something, to have some concrete, we need to have some information extracted from your images in order to determine or classify what kind of image this is. In recurrent neural networks, we will be dependent on the past information. We will have some past information, and that information will be used to predict the future. That has not happened yet. So 1 day data, 2 days data, 3 days data, 4 days data, and we will try to predict the next day data. That has not occurred. Some of the sequential data modeling that we have, there are 3 types of, they can be 3 types of problems. Next step prediction, which I just explained to you. For example, we have a sequence model. It takes the input A, B, C, D, E, and it will predict your F. Okay. And in the classification, we will use this input using a sequence model to classify. Either it is good or bad, it is 0 or 1 classification, or we could have multiple classifications such as digit classification, as I told you already in detail in your lectures on convolutional neural networks. Then we have another type, that is your sequence generation. This is new to you for this lecture, whatever we have covered so far. So what is sequence generation? We will have an input sequence, and based on the information captured in this sequence, we will try to predict the sequence that we expect. This example can be used, for example, in machine translations. Machine translation, for example, language models. We are trying to translate from English. We are trying to translate from English, for example, to French. This is one example. You will give an input sentence, and then you will have to translate that into another language. And we are familiar with this in Google Translate, then we have Translate on the Bing, and you have different applications of translations. You have the applications such as Papago, Google Translate app, or on the web also it is available. So you're able to translate from one language to another. These are types of problems that we occur in machine learning that can be solved or addressed using deep learning models. So what is sequence generation, machine translation? So from one language to another, from English to French. Then we can also have speech recognition systems. That is an input audio signal, and using the audio signal and its features that are existing and how they are placed sequentially, we can use that information, and then we can recognize what these words actually mean. And then we have another example, that is image caption generation in your sequence generation. For example, you have an image with certain pixel, for example 32 by 32 or 64 to 56 by 256, 64 by 64, for example, pixel data in this image, and we will use that information to caption the figure, this image. In this image, this bird is flying. So this is also an example of your sequence generation. Okay, we have in recurrent neural networks, I gave the definition that the models, they can have cycles. Okay, I mentioned that they can have cycles. So how do we now we explain what are the cycles, what do we mean by that. Okay, so first you have an input. As any model that you have, you give in the input, these are your features, and this is your output. You have m size vector, for example, as input, and n size vector as an output. So you give the input, it will pass through your model, and here we have, in any hidden layer, we have the summation part and we have an activation part. So we will do the summation, and then we'll do the activation, and we will have one output over here. This output, when it goes through, for example, some algorithm, it would be within a range, for example 0 to 1, or it could be between -1 to 1, whatever activation function you have used. So you can have an output based on the activation function, and then this input goes into the next layer, hidden layer, or your output layer. This one additional step is added here. So the output that we have here, it is temporarily stored in these intermediate, okay, let's call them intermediate hidden output. So one is the output of the hidden layer, and one is the intermediate output, and this intermediate output will become the input when you give this is x1, then you have x2, then you have x3. So when x1 is given, you will give input, okay, and you will generate these values at the edge, and these will also be stored in your C1, C2 up to Ck, because we have k nodes. So this data is stored here. It's very dirty, sorry. I don't want you to get confused, so okay, so we give your x1 as the input, okay, x1 as the input, that will comprise of x1 to xm, and then the output intermediate it is hidden layer output. It is stored in these cells, in these nodes. And when we give your x2, we also give, not only give this input, we also have an input from the intermediate hidden output. It is also becomes a part for the next. Firstly, you will have only one input that is going here, but for the next time you will have an intermediate hidden output, and it will be added into your sum part at this layer.